Hello everyone, welcome to week 3 of the class. Today we're gonna starting our new lab, which we're gonna work on Tableau and compare it with what we are gonna do also in Excel. So before that, let's quickly review what we did last week. So last week we talked about different measures of central tendency, and we learned that that basically shows the center of the data. We can use mean, median, and mode to measure that center of the data. Then we talked about different applications of the percentage, and we learned about different measures of the variability, like range, interquartile range, standard deviation, coefficient of variation. Basically, we learned that we could use all this information to describe our data, to summarize our data, to see what the center of the data is and how the other information, the other individuals compared to that center, how they are spread in our sample, in our data sets. Depending on the data type and the variables, we're gonna choose different measurements of the central tendency or measurements of the variability, and depending on what the distribution shape is like. Next, we're gonna be applying these measures, these topics in Excel and Tableau. But before that, let's see what Tableau is. I don't want to turn this um, into a lecture, so because we're gonna look into every detail of Tableau during the semester and also this session. So I'm just quickly going to mention some stuff, basic stuff that is gonna be helpful for you to start the Tableau. Please give me a second. Um, okay. So Tableau is a software that helps us to see and understand the data very quickly. We visualize the data, we see what is happening in the data, and then we use it to make decisions in the future for our business and for whatever topic that we care about. And using that information, we can analyze the data very quickly inside this software. But there are some limitations. For example, it is very costly. There are some limited ways to prepare the data, work with the data, and there are some performance issues when the data set is very large. And sometimes there are some customization constraints, not only for the data, but also for the software itself. But it's a very good way to quickly just see what is happening inside our data set. So the Tableau has dimensions and measures. Dimensions are the categories, the variables that are considered as the dimensions like name, dates, geographical data. These contain some qualitative values. And the measures are actually the numbers that we're going to use them to aggregate. See, for example, see the averages or measures of central tendency or measures of variability, for example. Also, the data type in Tableau matters in our analysis. So we're going to be sure what type of data we have before we start working with the data set. For example, we might have string data sets or dates in our variables or date and time values, or the data could be numerical or Boolean, or geographic values, or the image roles or cluster groups. We talked about different types of the variables in the past, so I'm gonna quickly just skip this part. Um, And please make sure to just quickly skim through that. For example, I have some definitions for each of those variables in the slides, like a string that is some text or sequence of characters in our variables, like customer names, product categories, country names. And in Tableau, we use this icon. This icon is used to show the string or text variables. Uh, or we talked about different numerical variables. These are the numbers. This string is basically the same as the categorical variable that we discussed earlier last week. Uh, and we have dates or date and time or the Boolean, which is the same as the binary variable that we talked earlier. It has two possible values for that variable. And geographical data is also another thing that has the globe icon in the Tableau. I'm going to show these in the environment of Tableau later on when we talk about each of these. And we could have a image role for our variables in the Tableau as well, or we can use the cluster group. So to understand these stuff or work with the Tableau and Excel, we're going to be using HECM data today, home equity conversion mortgage. So the home equity conversion mortgage is a reverse mortgage program insured by the Federal Housing Administration that allows homeowners aged 62 or older to convert part of their home equity into cash. And this HECM data includes those loan level data, individual level data that we're going to be working with that today. And here the rest of the slides just shows you each part of the environment of Tableau just to help you to start with. But again, as I said, I'm going to be working with Tableau right now, so we're going to be discussing about each of these parts later on. But make sure to go over these slides at your convenience, so it will be helpful to remember and remind what we discussed in the class, okay? All right, and one more thing, just to make sure that we all are at the same page, Tableau can save the output of your analysis into formats, either as a workbook, which is going to have this extension. We talked about what extension means when we are working with different files. Okay, that's kind of showing what type of file is that and which software is gonna open it, right? And Tableau can have two different um, ways to save your workbook. And in this class, you're not going to use the Tableau workbook because I'm going to need to have your data set as well. So you're going to be saving whatever submission that you have for the assignments using packaged workbook, which has this extension. Okay, not TWB. You're going to use TWBX to save your work and submit it through the assignments on Canvas. All right. So here is what you're going to do on when we are working. I'm going to show each of these steps, but you're going to just open File, click on Save As, and select the packaged workbook. And you're going to select where you want to save your document. And after you save, you can just upload it on Canvas for me. Then I will have access to all the work that you have done, plus the data set. Okay, let's start working with lab 2. Okay, so to start lab 2, first we need to make sure that we have completed the steps in lab prep after the week 2. So if you go back to week 2, you will see this lab prep for lab 2, and that opens this page for us, which has some information about how to install the lab. You're going to use the code that I have shared with you. Then watch this video, which is going to provide you some basic information to start working with Tableau, and then download this data set, which is the same as this one. The only difference is that this is a text file. So it's going to download a CSV file, and this is an Excel file, which is going to download an XLSX file. Okay, so I have already downloaded this data set over here, and I have both of them. Next, we're gonna be working with these data sets. Okay, let me just go to lab 2. I have already installed Tableau, and I have worked with, I have prepared the Excel files, downloaded the Excel files. So what we're gonna do, we're gonna simply start with okay, let me open these dataset files. All right, so here is the data set that we're going to be working on, the HECM file, download the XLS file using the lab prep link, and save it, save both CSV file and this file in one folder. We're going to be working in the same folder, especially it's going to matter when we want to work on Tableau, okay? So here in this Excel file, you will see some information about the file itself, how the file is organized. Then you will find some information about HECM dataset. Then you have the dataset itself with variables over here at the like as the header of these columns. And then we have the definition of the variables in the last sheet of this Excel. Okay, so let me lightly okay, zoom in. Uh, all right. So the first step for lab 2 is to open this Excel file, see the definitions over here. So lab 2 is asking us to open this lab 2 and lab prep. If I go to the lab prep, it is asking us to go to the definition worksheet and uh, read these definitions and create a column and name the column as level of measurement. Okay. And based on whatever that variable is, we're gonna select one of the uh, data types, either nominal, ordinal, interval, or ratio. Okay, we're gonna just write one of these 4 categories in this column for each variable. Endorsement date is an interval variable. It's a calendar date. Weekday is an ordinal data, ordinal variable, because we have day names and we can sort them Monday, Wednesday, Tuesday until Sunday. And we have initial principal limit, which is the ratio data. It has dollar amounts. Uh, it has some, when we have zero, it means zero, and below zero, it means there is no existence of that loan, okay? That's why it is a ratio data set, ratio variable. Interest rate is also a ratio. Loan data, loan type is nominal. We have maximum claim amount, which is a ratio, because if you read the definition, you will see that it has dollar values. So then we have this nationwide mortgage licensing system, which is also nominal. It is an identifier. Then we have originating mortgage. It is also nominal. It is name. We have originating mortgage number. It is also nominal. It is ID. It is identifier of this data. And we have property CD, that is also nominal. Okay. We have property county, which is also nominal. Property state is nominal. And we have property zip code, which is also nominal. All of these geographic information are nominal. We have purchase or refinance. It is a binary. It could be just recoded as a binary category, a binary categorical variable. It is also nominal because it has only purchase and refinance, only two options inside it. Then we have sponsor name. It definitely is nominal. And we have sponsor number. It is also nominal. Okay. Then we have sponsored originator. It is also nominal. And we have standard or saver, that is also nominal. Okay. So you see that none of these are unnaturally ordinal in this data set, except we can categorize this weekdays as nominal, as ordinal. We're gonna just treat IDs, codes, and names, all of this information that we talked, these geographical spaces, as a nominal, even if they look numeric, even if they have like zip code, even if they have numbers inside it, they are not numerical, okay? We use those numbers to just name specific areas. And so we're going to say that they are nominal, whatever that is, a measurement for money or rates. These are ratios and intervals, and dates are typically intervals. Okay. So let me just save this. I will save it at the end. Okay. So in the lab, the first step about the Excel, let's go to lab 2. This is what we were expected to do in lab prep about this Excel file. And let's go to the lab. In the lab, the first part is asking us to just create the measures of central tendency for the interest rate, right? So we need to go to the data set. We're going to open this data set, go to the sheet that we have the data, and then we're going to just turn this data into table. We can either just select Control T and it will open this window for us to turn that into a table, or we can just simply select format as table and select one of these and it will open the same window over there, just like this one, okay? And your data has the headers, so keep this checked and hitting the OK. It's going to create a table with all of these arrows that we could use to find the data sets or sort the data set and work with the data set inside the table, okay? And then we're going to find the interest rate variable over here. Let me slightly zoom. So here is the interest rate. Do you see these triangles here just next to these numbers in this column? That means that this data set type needs to be changed. The data set type is like a text, but we're gonna just change it, convert it into numerical. And you see they are all left aligned, just like these other variables, which are strings or text, but these are the numbers, the standard, the interest rate are the numbers, numerical. So we're gonna just change them in this format. But how are we gonna do that? The first way is to use this triangle and convert this into numbers. This is one way to do it. Another one is just to go to the first select the whole column by clicking on the at the top of the column, then go to a data tab and select the text to column and click next, next, and finish. You see all those triangles just disappeared and the data set just converted into numbers, just like these columns that we have here as numbers, okay, as numerical data sets. All right, so the next step in this assignment for lab 2 is asking us to generate the measures of central tendency. We're going to use pivot table that we've learned before, and we're going to be working with some formulas in Excel, okay? So what we are going to do, I'm going to go to the insert, create a pivot table, and it automatically brings the name of table for me. So last session, we did not talk about how to change the name of the table. If I click somewhere on the table, click on this table, I can just change this table name, okay? Let's just keep it table 1, and I'm going to go back to insert, create pivot table, and I'm going to type table 1 over here. To keep the data set clean, I always create the pivot table in the new worksheet. So I'm going to create this here. And the pivot table, we're going to drag the interest rate to the values. Let's find the interest rate. I'm going to drag this interest rate to the values, okay? It automatically brings sum over here, and I'm going to change it into average because that is what the lab 2 prompt is asking us to do. And we're going to have the average interest rate generated and calculated here. For the median, And mode, we do not have any options in the field settings. See, we do not have any median or mode options. So what we are gonna do, I'm gonna use formulas in the Excel. Let's have median in this column and mode in this column. All right. So for median, I'm going to use this formula. When we want to use the formulas in Excel, we need to start with an equal sign and write, like type the name of the function that we are interested in and we need. It's going to give us some suggestions over here. If that's the case, you can just double click and click on the name and it will be added over here. If not, you can just continue typing. So you're gonna and just have the left parenthesis, and we had table 1, right? And inside table 1, I'm going to use interest rate. This is the name of the column. Hitting the enter, it's going to give me the mode, okay? Sorry, the median. For the mode, I'm going to use this function, equal sign, mode, that SNGL, left parenthesis, name of the table that you want to refer and create mode based on that, name of the column, name of the variable actually, okay, interest rate inside the brackets, then we're gonna close the parenthesis, the right parenthesis, hitting the enter is gonna give me the mode for this, okay? Uh, let's rename this sheet to central tendency or interest rate. Okay. All right. Uh, we have this table over here that we can change the design of it if you want, or keep it as it is. But the question, the next part of the assignment is asking us to create the interest rates by weekdays inside this pivot table. So what we are going to do is okay, what we are going to do is just we already have the weekdays over here. Let's go back to the data set. Let me show you the variable related to the weekdays. So we already have this variable over here in our data set. We're going to use this to create some categories for this central tendency measurements. All right. So what we are going to do, I'm gonna just go back to this data set and I'm gonna insert pivot table. Again, I want to have it in a new sheet, and I'm gonna have interest rate again in the values, but this time I'm gonna have weekdays over here. What you see here shows the average of, I'm gonna select the average from the field settings, and as you see, this table, this pivot table shows the average of interest rate per each day of the week in each row. So it calculates the average interest rate for any loan on Monday, for any loan on Tuesday, on Wednesday, Thursday, and Friday in different rows of the table, okay? For now, let's keep it like this. Later in the next part of the lab, we're gonna learn how to change these 2, 3, 4, 5, 6 into name of the weekday, okay? We're gonna look into that later on. So let's go back to the data set. All right, and excuse me. So this time the next part of the assignment is asking us to create a categorical interest rate variable using VLOOKUP, okay? So what we are gonna do, let me just go back to the interest rate. So what we are gonna do, first, I'm gonna create a new sheet. In the new sheet, I'm gonna have a small table with the categories that I want to just simply categorize my interest rate. Let's have lower bound and let's have rate group. So let's have 0, 0 for lower bound, 3 for lower bound, and 4 for the other lower bound. Okay, then we have 0 to 2.9. This will be one of our categories. We want to create some categories that each of the observations in interest rate will fit inside inside one of these categories. Okay, so I'm creating a categorical variable instead of a numerical variable over here for the interest rate. And for that, every number between 0 and 2.9 is going to be in this category. Every number greater than 4 and smaller than greater than 3 and smaller than 4 is going to be in this category, and any number or any interest rate greater than this is going to be here. So we're going to just convert this into table. You can either use Control T, or if you are using Mac, Command T is gonna open this, or you can just select Format Table from the Home tab, and it will create a table over here. If you want, you can just rename this. Let's call it interest rate range table. Okay, so we're gonna go back to the dataset sheet, and we're gonna create a column on the just next to this. You can either use the last column of table over here, or you can just simply generate one over here. And for that, you can click on the cells and click insert. It's gonna just add a new column on the left, and in Windows, you can select in which side of that column you want to be created, right or left. Okay, let's rename the column into an interest rate group. Okay, and then we're going to use VLOOKUP command, which is something you learned about in the pre-lab. It is a function that helps us to look up for some values in our data set and in a referencing to a table. And here we're going to reference, we're going to just use this table of the table range, the interest rate range table that we use to refer to this and create this column based on these numbers. but it will be a categorical variable, not the numerical, just like this one. Okay, so let's see how we can do that. We're going to use the function VLOOKUP. Okay, you see, it just gives me suggestions over there, and in these suggestions, it has more information. What should I put here? It's asking me, what should I look up? I want to look into this column. Okay, so I'm gonna say look up this, comma. Do not forget these commas. Okay, then it is asking me um, what is the reference table, in which table I should look up this value. So you're gonna use IR range. You see, it gives me some suggestions over here. If not, you just type the whole name of the table that you created. Then continue with comma, then it is asking us what is the column index number. So in the table that we created, this IR range, the number that we are looking for, or the category that we want to use, is the second column. Okay, so I'm going to use 2 for the second column. Next, it is asking me if I want the approximate match or exact match. Given that I'm using approximate numbers over here, like close to 2, close to 3, or etc., I'm going to select the approximate match. I can type true myself, or just use the options and suggestions that the app is suggesting me. Then close this, have the right parenthesis, hitting the enter, it's gonna just change all of these into a categorical variable. See? So I have created a categorical variable based on the numerical variable that I have, given that wherever this number falls, in which range, this is going to just give me a category related to that. Okay, let's call this as IR range table. Okay, interest rate table, and this one was weekday central tendency. Okay, let's go back to the data. Let's see what is the rest of the lab 2. Okay, we created the pivot table based on the weekdays, then we used lookup to create categorical interest rate variables. Then it is asking us to create a pivot table to examine counts and percentage of loans in each group. All right, so let's go back to the data set. This time we're going to use this column to create a pivot table and count the categories and the percentage, like what percent of data is in category 4, what percent is in this category, and what percentage of the data set or observations are in this category. So what we are going to do, again, we're going to create a pivot table in a new sheet using the same table. Okay, so just in case, if we do not have, you see, we do not have interest rate group here, the new variable over here. So to fix that, go to this tab, pivot table analysis. Okay, and in the pivot table analysis, click on refresh, and you will see this interest rate group variable is just created. Okay, or refreshed and added into our list of variables in the pivot table fields. Okay, so what we're going to do is we're going to have this interest rate group dragged into the rows and the values. Okay, so the rows are going to show each of those categories that we created, and This is basically on the count. We do not need to change this. It automatically gives us the count of each category that we have over here. It just counts them and gives us these numbers. Okay. To show the percentage, we're gonna, let me add one more of this here, but this time I'm gonna, if you're on a Mac, select, just right click. We discussed about this earlier in the previous lab. If you are on the Windows, you're gonna have a small arrow over here that you're gonna click on that and it's gonna just open that, okay? Or you can also click on this information, then opening the value fields, then click on show the data as or to show the value as. Then select the percent of grand total or the columns total. Okay. And then select OK. It will give you what percentage of the total data is inside this category, what percentage of all the observations are inside this category, and what is inside this category. So pause the video and think about what each of these numbers mean and what information I can get from that. Assuming that you paused, so in this class, we learned that we are going to care about analyzing data and making decisions. We want to see the story behind these numbers, not calculating the numbers. This is not only just learning how to work with the softwares, but we also want to learn the meaning of each of these numbers. Okay, looking at this information, one thing that they can learn is that, see, most of the data set are in the expensive or the higher rates of the interest rate. 60%, more than half of the loans are in the 60% of the loans, more than half of the loans are in the interest rate above 4%. You see, so it means that it's kind of an expensive loan. They are mostly expensive loans. Okay, so when you create these pivot tables, always think about the meaning of these numbers. Okay, uh, even looking at these numbers, you will say that, okay, this is larger number. It's way larger than these. But if you want to make even a better sense of these numbers, you decide to change them into percentages. You see, looking at the percentage, comparing the different categories using percentages is much more easier. Okay, so let's rename this into interest rate group percentage, right? Let's go back to the data again. The next part of the question is asking us to try using VLOOKUP to create a day of the week variable called weekday name that contains the name of each day. So this is what I said earlier that we're going to be working on. Our weekday variable over here has the numbers instead of name of the weeks. Like this should be Monday, this should be Tuesday. And I know that based on the definition. If I go back to the weekday, let me find the weekday in here. See, it is explained here that 2 is equal to Monday. Okay, if you do not know the meaning of each of these numbers, always go to the metadata of the data set that you have downloaded or this definition of the variables, and you can find out what each of them mean. Then using that information, you can just rename these in your tables. All right, so what we are going to do, we're going to just work exactly the same as what we did to create these categories, no, but slightly different. So let's create a new sheet, and we're gonna have two columns again. We're gonna have 1, 2, 3, 4, 5, 6, and 7 for 7 days of the week. And then let's call this column as name, which is going to be Sunday, Monday. And if I click on this, it's going to automatically fill the rest of the table, okay, the rest of the information. Next, I'm gonna just format this as a table. I'm using Control T or Command T, and this is gonna be the new window being open. It turns this, it converts this into a table. Let's call it as day lookup range. This is the name of the table. It is going to help me to easily just use this name when I'm working with VLOOKUP. Okay, so let's go back to the data set and we have, let's use this last column over here and let's use weekday name for the name of the variable over here, just like what the assignment is asking us. The assignment told us to create this variable that is called as the weekday name, okay? Then I'm gonna use a VLOOKUP function. So first I'm gonna enter equal sign, then VLOOKUP, and then I'm gonna have left parenthesis. What are you gonna look up? I'm gonna look up this value, okay? What is my reference table? Where I'm going to have that table to look up this value? That we called it as day lookup range, okay? Then I'm gonna have comma, then it's asking me what is the column that I'm going to use or index over here. Again, I have the names of the weekdays in the second column, so I'm going to use 2 to show the second column. Then this is going to be the exact match, not approximate match. It is going to be exactly the name of the week, so I'm gonna have false here, and then the right parenthesis, and it's gonna fill in down all the observations with their related names. Like 5 is gonna be Thursday, 6 is gonna be Friday, 2 is gonna be Monday, and etc. Okay. All right, so the next part of the question is asking us to create another pivot table that is requesting us to have the average of interest rate by weekday name variable. Okay, if you look here, we do not have weekday. Pause the video and think about what I said. How to how to add that new variable inside this box or the pivot table fields. Assuming that you paused and thought about it, so we're going to go to this pivot table analysis tab over here, okay? Then I'm going to click on this refresh, all right? And then I'm going to have this weekday name over here. Let's drag and drop this weekday name into the rows. Next, I'm gonna have interest rate variable in the values, but it gives me the sum, so let's change it into field settings. Select the average because I'm interested in the average interest rate of each loan for each day. Then it's gonna give me this information, average interest rate on Monday, average interest rates of the loans that are issued on Tuesday, and the other days of the week. So this is the next part of the question, then it is asking us to create the loan counts and the percent by the interest rate group as well. All right. This time, let's create the loan count. If I want to create the loan count, I'm going to have the interest rate group and the rows, right? Let's create a new pivot table. And in this pivot table, I'm going to have interest rate group in the rows. All right. And another interest rate and the values. Okay. And it's going to give me, so yeah, this is exactly what we did before, sorry. It's basically the same thing that we had here in this one, okay? So this is the last part of the Excel file that we want to have. So just to create all of this for this assignment, work on all of these tabs, rename these tabs accordingly, properly. So when I look into the tabs that are created, so I know what you have done over there, then go to the Save As button. If you are working on the Windows environment, you're going to go to the File and select Save As, okay, or Save a Copy. Or in the Mac, you have this button over here to select Save As, okay? So let's go to Save As, and let me just save it somewhere. Name it like this. For example, use your last name, first name, lab2, that XLSX, okay? It's going to be selected like XLSX automatically, if not selected as XLSX. Then save it at the destination folder that you are interested, so you can find it easily and upload it through the Canvas. Okay, so this is the Excel file. I'm gonna stop the recording here, and then we're gonna continue in the next video with Tableau part.